Hi, everyone. Thank you for joining this session today. We are going to spend the next hour together learning more about how Netflix is reimagining multi-account deployment for security and speed. My name is Prateek Sharma. I'm one of the senior solutions architects with AWS. I've been very fortunate to work closely with Netflix for the last 3 years. Netflix is an amazing company with great culture and brilliant team of engineers. Today, I have the honor to introduce Patrick Sanders and Joseph Kerr. They are senior security engineers at Netflix. They're both part of cloud infrastructure security team. This team has done some of the most phenomenal work in the last 3 years that I've been with them. They've shared their learnings previously, and today they're going to share some of the most creative work I've seen around this topic. As you guys are aware, AWS accounts allow you to have strong isolation boundaries. And we have always recommended our customers to take advantage of these boundaries to logically lay out separations of concerns and reduce the scope of impact. Netflix has leaned into it and has come up with a very creative way to reimagine how multi-account deployments can be used for security and speed. I think it's a really cool setup, and you're going to have a great time learning more about it. So welcome, Joseph and Patrick.
Thank you so much, Prateek. Prateek is absolutely amazing. A huge shout out to our AWS account team. They're phenomenal to work with, and they've been a great sounding board as we've revised our ideas and told them about the crazy things that we want to do. So can't thank them enough for their help. And we thank each and every one of you for being here with us today. We're so excited to tell you about this. We'd like to tell you the story of Netflix's multi-account journey, where we've been, where we are, mistakes that we've made, and most importantly, a really awesome new approach that we're working on right now. So at the end, we will leave time for questions. And so we'd love to hear those from you and get your feedback and talk to you. With that, I will hand it over to Patrick to talk about Netflix and AWS.
Thanks, Joseph. So, as you may know, Netflix has been in AWS for a long time. Our migration to AWS started in 2008, which was 3 years before IAM even existed. These were the days of EC2 Classic and just a lot of wild stuff. And it was also before we had all of this nice multi-account tooling like AWS organizations. Oh, I don't know how to work this thing, sorry. We're also really big, and a lot of our early growth happened in a single AWS account. That primary account is still our primary account today, and it's massively multi-tenant. We have 7,000 microservices at Netflix. That translates to about 2.5 million workloads across EC2 instances and containers. A significant portion of those workloads are in this massive multi-tenant account. There are good reasons that we've ended up here, but it's not really sustainable, and we need to do something about it. A few years ago, we tried to do a multi-account migration, and it didn't work very well. The migration was way too burdensome, and we were able to learn a lot about how to come up with a better approach for doing a migration without as much burden of migration. Because of this multi-tenant account, we've also put a lot of investment into privilege. You may have heard of a tool called RepoKid that automatically removes permissions from roles when they haven't been used for a certain amount of time. And we also have a tool called ConsoleMe that application owners can use to request permissions for their applications. But even with these investments in these tools, achieving a semblance of least privilege in this account is really difficult. So why bother with multi-account in the first place? Well, we have a lot of operational risks in this account. Those revolve around things like rate limits, service quotas, and we're nearing some hard quotas on several resources. Additionally, a misbehaving application can cause availability impacts for unrelated applications. Next, we have security risk. There's lots of implicit access that applications get when they're in this account. So At Netflix, we've optimized for developer velocity. We want people to get their work done and get those movies to you as quickly as possible. But because of that, a lot of our policies aren't as well scoped as we'd like them to be. RepoKit helps, but there's only so much that it can do. And we want to be able to take advantage of account boundaries because of the robustness of their isolation. Next, it's not a good experience to live in this big account. We have to impose a lot of restrictions on our developers, like we can't let them use CloudFormation. We can't let them delete a lot of resources. They can't modify IAM policies directly. There's a lot that they can't do that just kind of gets in the way, and they have to involve us to get their work done. And finally, aligning with best practices. AWS has published a really great white paper called Organizing Your AWS Environment Using Multiple Accounts, and I really recommend reading that if you haven't already.
Thanks, Patrick. So with those benefits in mind about going multi-account, we're also extremely cognizant of the challenges, particularly after that failed migration that we had some time ago. So we sought to understand these challenges as best as possible, and it really boils down to three things, right? That moving an application, its resources, and its associated infrastructure is one, very, very complex. There are always more moving parts than you think, and when it seems like, oh, all I need to do is pick up this one piece and put it over here, there's inevitably a cascading chain of things that are affected that you may not have even known about. Two, it is slow. When going from massively multi-tenant accounts like ours to trying to segment everything, the number of teams involved is generally very, very high. Often those teams have competing priorities, and getting everyone aligned from start to finish is next to impossible. Finally, it's really expensive, both in people cost and in infrastructure cost, and most importantly, in the long-term maintenance and operational burden. That's something that's often underestimated, and even when a migration works, the central platform teams left trying to manage their infrastructure across maybe dozens or hundreds of accounts are often very strained and unhappy. So thinking about those challenges, there are more specific things that we can refer to as well, like managing and monitoring east-west traffic. Like let's say you're going massive multi-account and now you have VPCs and thousands of accounts. Managing traffic that way is really hard. No one likes managing security group rules or routing across that many accounts. There are some tools like VPC sharing and private link that can help alleviate that, but the management is still hard, and there's not really a good or elegant way around it. So with the benefits that we're seeking and those challenges in mind, we decided to revisit our approach to AWS account management. And the first thing we knew we had to do was establish a really robust account lifecycle, which basically covers these important questions. One, how do you create your accounts? How do you provision them? And two, how do you deliver them to customers? And in this talk, we'll cover what we're doing to solve these challenges, but this is not meant to be a prescriptive, this is the perfect way to do this, more of this was necessary to get to where we want to go. And hopefully there are some things that are educational about that. Along with account provisioning and vending, there are a lot of complementary systems, right? Infrastructure as code tools, account inventory systems, AWS organizations, a lot of things that can really help ease how you manage your AWS accounts. And one thing that we decided to do in our organization was set up our OU structure to reflect where an account is in its life cycle. So at our very top level under our root, we have an OU for newly created accounts that are yet to be used, that don't have an owner assigned. We have an OU for accounts that are active and live, and finally an OU for accounts that have been deprecated. This allows us to easily set policies based on what that lifecycle stage should mean. within each of those accounts. And ultimately, as you do that, you'll be optimizing for long-term security and manageability. One thing that we would highly recommend against is setting up your organization structure and your OU structure to mimic your organization's HR flowchart. That happens all the time. The organization will inevitably reorg itself 1,000 times, and what you're left with in AWS looks nothing like what your organization is anymore. So do it based on security policy need rather than what your org looks like at a given point in time. So to start off with the account provisioning story, we maintain a pool of pre-provisioned accounts that are ready to go, that are ready to hand out to customers. We do this using a workflow pictured here. We basically use a simple Lambda service to ensure that at any given time we have X number of accounts ready to go, ready to hand out. So this provisioner is really quite simple. It calls the organization's create account API, gives the accounts random names, and puts them in that created OU that we saw before. This is another thing that we've learned is that account names are a really bad place for account metadata. The use of an account can change substantially over time. Its owner can change, and so naming an account hyper-specifically can often result in confusion down the road. So we give them random names and add them to our account inventory system. That's another thing that we'll call out here because not everyone has one. A lot of people rely on organizations for their source of truth for all information about their accounts. And that's fine, but as you scale up, having a separate account inventory system is really, really useful. And so that's definitely something we recommend doing. Once these accounts have been created, we try to provision as few resources as possible. That basically boils down to admin roles, setting up CloudTrail, which is really just handled by organizations, setting up config the way we want it, some basic security event forwarding, and turning on some security services such as guard duty. And you'll notice here there's nothing about networking. And we'll get to that later. But by following this minimal provisioning process, our account creation time is on the order of seconds rather than weeks. And so Patrick will talk about how we give these out now that they've been created.
Thanks, Joseph. So now that we have a way to create these accounts, how do we get them to an application? Well, we do that with a tool that we call an Accountmapper. It's just a Lambda function, and what it does is it pulls an account from that Lifecycle created pool, and it maps it to the application and the owner. The account mapping is recorded in a couple different ways. We update some account tags in organizations, and we also update that account inventory system that Joseph was talking about. And then after that, we move the account to the Lifecycle active OU. Next, we provision roles for the application and the application owner. Now, the application needs an instance profile role. Well, we'll talk more about that later. But so the applications will launch with a role from this mapped account. And then the owners of the application get a web console role that they can use for either CLI or web console access. And then as soon as we do that, the mapper loses access to provision roles in the account as soon as the account is set up. Oops, I missed something. So we don't want users to have to worry about requesting accounts. That's a question we get a lot, is what does it look like to request one of these accounts? So what we do is when you launch your application via our CI platform called Spinnaker, Spinnaker will check to see if your application already has an account assigned to it. And if it doesn't, it'll invoke our mapper Lambda. That Lambda will do all this work and then return the role ARN that Spinnaker uses to launch the workload. So by doing this, we get humans out of the process entirely. And a migration can be done simply by just redeploying an application. So in the diagram that we have here, you can see that the Lifecycle created has 3 accounts in it. So we pulled this Rinkomania account out, put it in Lifecycle active, and do this work in it to create the roles, and then just pass the information back to Spinnaker. So you might be thinking, wait a second, this is all just normal multi-account stuff. This isn't anything new. So what's the big deal? It's great that we can easily create these accounts in a matter of seconds and then vend them out. But what do we do from here? So we want to have 1 account per application. But if we start handing out accounts like candy, how are we going to reconcile that with our existing infrastructure? How are we going to overcome the challenges that we were talking about before, like managing VPCs, app connectivity, delegating permissions, all of that nasty stuff? So there are a few options. And while these might be good options for a lot of organizations, they don't work for us for various reasons. We could do VPC peering and extend our flat network. We could have separate VPCs, use transit gateways to route between them. We could share VPCs across accounts. We could have strict security controls that force infrastructure conformity within each account. Or we could have a sandbox model where we let everyone mostly do what they want and expose services via standardized interfaces. Well, all of these options had some pretty serious flaws that didn't work for our infrastructure and made them a non-starter. So how do we get our apps into these accounts without exponentially increasing operational and security complexity? So we realized that most of our problems stemmed from infrastructure-related concerns, like VPCs, EC2 instances, that sort of thing. It became clear that we needed to do something different.
So this really got us thinking about some core assumptions that we had been making about AWS and how things work. And we ultimately landed on a pretty important and influential question that kind of changed our whole thought process, which was, why does an application's IAM role have to be bound to the underlying cloud infrastructure? You know, when you spin up an EC2 instance and you choose a role, why does that role have to come from the same account? And really just because it's always been that way. It's something you don't normally think about. But the more we started to think about that, the more we realized how much power we could unlock by decoupling these things that are really just kind of artificially bound. You know, if we could place a cloud identity in an isolated account where network-based resources aren't allowed to exist, then a whole slew of problems associated with multi-account migrations and deployments would just kind of disappear. And so let's try and let that sink in a little bit. What if you could do multi-account without VPCs, without EC2 instances, needing to live in all of these remote locations? You wouldn't have to worry about network connectivity or infrastructure, right? Half the battle in setting up a new account is getting everything connected, setting up your VPCs with usually non-overlapping CIDR blocks, setting up your transit gateways, setting up your VPC endpoints, your security groups, your subnets, your NACLs, all that network stuff. What if you didn't have to do that? Likewise with EC2. Managing security for EC2 in 1,000 accounts is very, very challenging, right? You have to do vulnerability management. You have to make sure that the images they launch with are present or shared to all of the accounts. You have to have remote access solutions that allow you to get to who knows how many different network locations to connect to the instances. You have to set up security logging for these things and make sure that it's all piped in from these disparate locations. It's really, really hard. You know, largely why our first multi-account migration kind of fell flat. So, without further ado,
So our dream is to decouple each application's cloud identity, its IAM role, from its network, compute, and other platform resources. So in line with the Netflix culture of freedom and responsibility, we want to give app owners the freedom to have near admin permissions in their accounts. We want them to be able to create buckets, queues, use CloudFormation, all of these nice things that just make AWS better. But we don't want them to be able to launch instances. So we want to keep all of the hard stuff centralized. We really love our platform teams. We have some of the most incredible talent working on compute and networking and storage, and we want them to be able to do their jobs without us getting in the way. So they can manage all of that in their centralized accounts without having to go through some of these burdensome migrations or align with us on how to architect this new account strategy. So with this, instead of strict rules enforced by an IAM policy, a workload's identity becomes its sandbox. So we have a very simplified diagram here of what this looks like. We have an account with all of the networking, an account with all of the compute, and then a dedicated app account that only has this application's IAM role and its cloud resources. So it's a neat idea, but there are some problems. AWS doesn't support this out of the box. So to make it work, we have to solve these two problems. How do we exchange a workload's identity for AWS credentials? AWS can no longer give us the creds that we want by default. Next, how do we expose these credentials to the workload? Instances and applications can't be impacted by all of this wild stuff that we're doing. We can't expect application owners to update their code across thousands of applications because that just becomes a mess and it will never get done.
So for the first problem, Credential Exchange, let's review a little bit of how that works today. You assign an IAM role to a given EC2 instance at launch time, and AWS natively exposes credentials for that role on the instance metadata service. Here in the diagram, you can see the instance metadata service listens on every EC2 instance at a static IP address it's a link local address at 169.254.169.254. And you can make simple HTTP requests to this interface to get a whole bunch of metadata about your instance, including those default role credentials for the role that you assigned to your instance. So the IMDS is really, really powerful, but also really important. If you get in its way, a whole bunch of stuff will break. Most applications are unaware of it. They use the AWS SDK to make their AWS API calls, and when they do so, the SDK, which is IMDS aware, goes and asks it for what it needs. It's also important to note that some things that don't use the SDK may choose to use the IMDS directly, and you have to be aware of those as well. So here, in the diagram, we've just pictured default application behavior in AWS. An application starts up, it issues a GET request to the security credentials endpoint, and AWS returns IAM role credentials for that instance's IAM role to the application. Now, with what we're talking about, the IMDS is no longer going to be able to serve the credentials that we want it to the target application, because those credentials need to come from a completely separate account. So how do we make that work? Basically, we need to exchange our workload's identity for the AWS credentials that we want. Workload identity is a separate talk. That's a really hard problem to solve. But if you have some way to assert an instance's identity, whether that's an X509 cert or an OIDC token, you can use one of those mechanisms to request AWS credentials from a different account. And we considered two options for Exchange. If using an X509 cert, you could use IAM roles anywhere, which is a new service that allows you to establish PKI roots of trust and exchange certs for IAM credentials. And we also looked at using STS assume role with web identity, where you exchange an OIDC token for those role creds. So that really forms the backbone for how we can fetch arbitrary credentials, so to speak. One question that comes up is, how do you make sure that you're exchanging for the right credentials, that the instance knows which ones to request, or that you're not allowed to request others? And we do that through a combination of setting an environment variable at deploy time that specifies the correct remote role arm to use for that, and then configuring our policies appropriately to scope which roles can be assumed. There are some alternate options for doing this, like for delivering arbitrary credentials to workstations, or rather to instances. But these two were really the most promising and really the only ones that we would recommend. Ultimately, we settled on, our current first preference is using OIDC tokens, because the STS assume role with web identity API call has a very high quota, so we don't have to worry about scaling issues.
So now that we have a way to get these credentials for the application, how do we get them to the application? Well, there are a lot of ways that we can do this. We could update the applications to make this assume role with web identity call themselves. We could configure IAM roles anywhere with its credential helper in the instance's AWS configuration file. But those have some shortcomings that we mentioned earlier, that we might have things that are interacting with the IMDS directly, and those would break if we don't support, if we don't make IMDS serve up the right credentials. So what we decided to do instead is build an IMDS proxy. It's a very simple proxy, and all it does is it stands in between the application and IMDS. And when a request comes through for the credentials endpoint, it intercepts that request and returns credentials from this assume role with web identity call. So the outcome of that is that there's a lightweight and easy migration experience, because we don't have to change any code. No application owner has to touch their application at all. So what does that look like? Well, we put together a very simple web application that uses IMDS to get the account ID of its network interface. And that's in an account called AWS test. And then it also uses STS get caller identity to get the account ID where the role lives. And that's in this AWS test DAA EC2 demo account. In this AWS test DAA EC2 demo account, I can now access the web console or use the AWS CLI to do way more than I could in AWS test. I can create and manage resources. I can use CloudFormation. I can deploy Lambda functions, and I can self-manage my IAM policies without having to get the security team involved at all.
So the outcomes are tremendous, right? It means that the security boundary has been reduced to a single account for a given application, right? The scope of an application compromise is now drastically lower than it was when all of the applications and all of their identities lived in the same account. We have maximum flexibility for other architectures. If our compute platform team comes to us and says, we want to change what we're doing with EC2, we want to completely redo this, move instances around, change a whole bunch of networking primitives, to us, we say, go for it, because we've decoupled ourselves from those infrastructure concerns. We get relief from a variety of rate limits and service quotas, because now our applications are making API calls in the context of their dedicated accounts versus all competing for the same piece of the pie in our giant multi-tenant environment. We get scalable, simplified permissions management. In all of these remote accounts where only the application identity lives, we get to grant near admin access with some simple guardrails, because there's no way that people can step on each other's toes in those accounts. And we improve developer productivity, as Patrick alluded to, because now the developers can go fast. They want to make a simple S3 resource policy update. They don't have to come to our security help channel, right? They want to do something that might be a little bit out of the norm. They don't have to consult with us and see, are we going to break something that we're unaware of? They can just go do it. Something that knows all those amazing benefits in mind. This is not a silver bullet for security, right? There are plenty of things that it does not do. It does not prevent network-based lateral movement, right? All of our networking and all of our compute infrastructure, as you recall, is still centralized. So compromises in those layers are still something that need to be thought about and dealt with. It doesn't prevent abuse of shared resources. If you have S3 buckets, databases, or like DynamoDB databases, things like that that are shared across all of your accounts, those things could still be misused. Your dedicated app accounts, yes, they're tiny. Yes, the scope of impact is small. But as an attacker, I'm pretty happy no matter what AWS account I gain control of. Because there's plenty you can do with an empty account, whether that's hosting malware or distribute or crypto mining, all sorts of things. And you also need to protect against events on centralized control planes, right? So things like a container escape are very, very dangerous still. This does not protect against that.
So as we look forward, we have a big migration coming. And there's a lot that we have to figure out before we can start moving these application identities around. If you missed it yesterday, our teammates did a talk on some SDK instrumentation that they did to help us figure out the behavior of applications and the resources that they use. Check out that recording. It's NFX302, really good stuff. We also have to figure out cross-account enablement. We have a lot of tools that we've built over the years, and those need to be updated to support this massively multi-account architecture. And then we have to do the actual migrations, which luckily don't involve any lift and shift of resources, but it still requires a lot of talking to different teams and making sure that everything is okay before we start moving things around. So before we wrap up, we want to give some special thanks to a former teammate and all-around great guy, Stephen Reiling, and also our AWS account team. They have been indispensable in this process of figuring out this architecture and strategy. So thank you. We'll take some questions, and appreciate you coming here.